Hello everyone, it's Mrs. Ruscio here, and I'm going to talk to you about 6.4 different forms of quadratic functions. Now, something that just makes me so sad is that some of your packets did not color copy, so really, it's just really tragic. But if you have a highlighter or 3 or 4 different color highlighters, this is what it should look like on your page too. I recognize that it's not there, but we're going to talk about all of these different forms that you see on the top of this paper. So we have standard form, vertex form, and factored form. And really, this is what I think makes the most sense to us as students. Like, this is what it looks like with numbers and variables all plugged in. Not with the A, the H, and the K. That looks confusing, but here is vertex form. Oh my gosh, that looks like kind of like what it did with complete the square. That's weird. And then factored form, oh my goodness, we factored so much in the polynomial unit. All right, so all of these different forms tell us different things about a quadratic graph. So if you look at the standard form here, the standard form is going to tell us whether or not the parabola opens upwards or downwards because of the negative not being out in front, or because it's a positive, it would open up. And it's going to tell us the y-intercept on the end of a function. The vertex form also can tell us whether or not it opens upwards or downwards based on that number out in front being positive or negative, but it can also tell us the vertex. It can't tell us the y-intercept. The factored form can also tell us whether or not it opens upward or downward based on the number out in front. This form can tell us the roots. So this function here is the same quadratic function written 3 different ways. It's this guy right over here, this graph. Okay, so this is why it's so special. A parabola, you can take an equation and you can manipulate it in a bunch of different ways using some algebra. Okay, so exercise 1 is saying what we have to do is identify the form, its features, and the axis of symmetry. Now, we have an equation that we can use for the axis of symmetry when we need it. It's right up top here, and it says axis of symmetry. So that's just something to keep in mind as we work through these questions. All right, number 1, part A. So it looks like we have 3 separate terms. It's written in what form do you think? Standard form is correct. I hope you were thinking that. So let's write down standard. All right. And if you look up above on the paper, I'm not going to keep scrolling back and forth. I'll just make you dizzy. But you can see the standard form is going to tell us whether or not it opens upward or downward. And Mrs. Hayes, I forget what she says. I don't know. It's like a Mad Max or like a Happy Mini, or I don't know, positive. I don't know what that is. But for my sake, this number out here is negative. So it is going to open down. And what else do we know? Well, we can figure out the y-intercept. So the y-intercept is going to be this number here. And let's write it as a point, 0, -9. Now, this, finding the axis of symmetry of these guys is not so easy. So what we're going to do instead is we are going to use that formula right up top. And that formula is x is equal to -b all over 2a. And we're going to know what that song is in just a few more videos. So stay tuned. So -b, all right, so x equals -b, which is our 5, A, B, C, okay? And then all over 2 times a, and that a is a -1, which turns into -5 all over -2, and a negative divided by a negative is a positive. So we're just going to write it as, let's see if I can scroll I'm losing some stuff around here. All right, I think this is better. Here we go. I'm going to just rewrite it as x equals 5 halves. Okay, or you could write it as 2.5, whatever, potato, potato. All right, B, what form is this? Well, it's definitely not standard form. If you guess factored form, you are correct. All right, and we know the factored form, I think you remember this from the polynomial unit. It tells us whether or not it opens upward or downward. That number is there, is positive. So we're going to say it opens up. You could also say concave up or concave down. That's a really fancy word. But it also tells us the zeros. Now, a lot of people might want to say x equals -5 and x equals +3, but we know better. We know that they're opposites based on what we talked about from Unit 5. So x is going to actually equal 5, and x is going to equal -3. Remember that. Now, here's a cool thing about this equation here. It's not written in standard form, so we cannot get A, B, and C and use the formula for axis of symmetry. But here's the deal. We have a parabola. I'm just going to do a quick little sketcheroo. Okay, we have a parabola, and it's cutting the x-axis at -3 and +5. So what do we know about this axis of symmetry? If you answered it's halfway between -3 and 5, you are actually correct. So if we counted spaces, -2, -1, 0, 1, 2, 3, 4, 5. Boy, my points are off a little bit. My 5 is a little farther out than where it should be, but whatever. Here it is. This is 8 spaces. So if that's 8 spaces, from -3 to 5, right? -2, -1, 0, 1, 2, 3, 4, 5. You can count on your fingers. It's 4 spaces away on either side. So 4 spaces away here, 4 spaces away there, which means it's right at x equals 1. Actually, I should probably write that up here. That was so fun. Okay, C. This is the last and final form. This is the vertex form. And the features that it can tell us, well, the first thing, it is opening up or concave up. And it also tells us the vertex. We also call this the shifted form because if we rewind all the way back to Unit 2, isn't that 7 units to the right and 10 up? So 7 to the right, it's positive, and 10 up. I love the vertex form when they ask me to find the axis of symmetry because it's so easy, right? If we're looking at the point 7, 10 right here being the vertex, doesn't my axis of symmetry slice right through that x value? Yeah, so x equals 7. All right, heading on to the next page, 20. All right, so exercise 2, here we are. It gives us a quadratic function, and we need to find the equation of the axis of symmetry. Well, this is kind of where we just came from with those 2 questions. We've already done it. It must be important because they're asking us to do it again. So again, we're looking at a parabola. It has a vertex of the point 4, -11. We don't know if it's opening upward or downward. I don't even think it matters. But let's do an open upward parabola. We got to find this line here. And if that's the point 4, -11, that's super easy. X is just going to equal 4, that whole imaginary line that slices it right through the middle. All right, B. Same thing in B. We did this. We just did it. All right. So it has zeros at -2 and +10. So there's a giant U that's passing through these. Oh my, that's the worst parabola I've ever drawn. No, that's probably one of the best parabolas I've ever drawn. Let's be honest. All right, I'm going to try to make it look a little bit cuter. Okay, a little bit better. We're just going to put a point there saying that that's a vertex. Okay, don't judge me. All right, so it has to have an axis of symmetry right here, right down the middle. So if this is 2, that's -1. And then what we would want to do is count 10 spaces away. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So between 10 and -2 is 12 spaces, which means that there is 6 spaces over here and 6 spaces over there. 10 minus 6 is 4. So it's cutting the parabola in half, right at x equals 4. All right, exercise 3. Here we go. We are given 3 equations, and we need to find equations of all of them. Well, this is special. It lets us pick the equation we want to use, and I love that so, so, so much, because if they give me the roots, I'm going to use a factored form. If they use or if I can find the vertex easily, I'm going to use vertex form. Standard form is kind of annoying, but we can use that. I think we're going to go between those other 2 forms, because finding a y-intercept isn't going to tell us anything about those other 2 numbers of like the x squared and the 4x or whatever it might be. So let's look at A. I don't see nice, pretty roots, not even going there. But what I do see is a gorgeous vertex that's happening at the point -2, -5. So if I want to write an equation, first of all, I know that it's opening upward, so it will be a positive whatever this is. And a lot of people might want to write x minus 2, but remember, it's x plus 2. The inside is always the opposite. Squared minus 5. 2 to the left, 5 down. 2 to the left, 5 down. And that's it. That was so easy and so fun. All right, here's the next one. Ew, that vertex is gross, but check it out. I am loving those roots. But guys, remember, we did this all in the factoring unit. This is a perfect one for the factored form, right? Weren't the roots different than the factors? The signs were just the opposite. So instead of x minus 2, it was x plus 2. And instead of x equals 1, it would be x minus 1. And we're done. That was amazing. All right, C, what do you think? Wow, wow, wow. Look at this guy. He has a beautiful vertex, and he also has beautiful zeros. So you want to know what that means? We get to pick. We get to pick. We get to pick. I'm going to pick the vertex form. I think that's fun, and I think we could use a little bit more practice with it. So this vertex here is at the point 1, 4. But one thing that I notice, and I hope all of you are screaming this at your screens right now, is that the parabola is upside down. Yes, it's upside down. So negative. All right, let's shift this. It's 1 to the right, so it would be x minus 1. Yes, you are right. And 4 up from the origin. Remember, that's where the shifting is happening from. So that means it would be plus 4.